All right, everybody, welcome back to the DAC Pavilion. So on our next panel today, my friend Frank Schermeister from Cadence Design Systems will moderate a great discussion among some visionary panelists on what can EDA and the electronics ecosystem do for greener electronics to save the planet.
Thank you. Okay, yeah, get the water, the sustainable water out of the way here. So thanks for joining us, and thank you in advance to the panel. I'm really excited about the mix of personalities and companies we have today here on the panel. Just to introduce the topic here for really only 2-3 minutes of why, when I was asked to come up with ideas for panels, I came up with a sustainability thing. It's partly driven by my daughter, I would say. I have a 17-year-old who gives me a really hard time about, yeah, of course you pay for solar, that's fine, because we need to save the planet. And she's very interested in sustainability in general. And if I look at our industry, we are kind of the guilty ones a little bit in terms of enabling all these cool things which are our distraction, which are really across all those application domains consuming a lot of the energy today, right? So we have cloud, we have cars, we have all the cool devices tracking our steps and where we are. And if you look at what has happened over the last couple of years, specifically from 2010 to 2018, if you look at the whole flow of, and that's really what this panel here represents, of IP, of semiconductor with implementation, optimizing for low power, then putting that into systems, and putting that into systems of systems, which at the end, I can call my car right now to create climate, and also when I come back tonight. Over the last really decade, the whole data center consumption, as an example, has only gone up by 6%, only in apostrophes. But we got significantly more workloads, we got 10 times more internet traffic, and we got 25 times more storage. So it's huge in terms of what we have achieved with pretty much almost the same power consumption. And if you look at the information here where ICT is going, this is coming from a gentleman, his name is Andre in Sweden, who basically looks at how power consumption over the next 10 years might develop. So they make these predictions, updated every year. All the items we have here on the panel are represented: mobile, automotive, the whole industrial parts, the data centers. Well, there's a worst case and there's a best case of where this can go, and our responsibility as an industry is probably to get this as close to the best case as possible, which really dealing with energy, with climate, and then even with some of the societal aspects, right? Getting the technology accepted with security and everything, that if I give all my data out there for energy consumption optimization, that nobody hacks into it and so forth. So we have a responsibility here as an industry, and that's why I brought together a group of experts here really representing the whole ecosystem, and it works out really nicely. We can, I had planned to start from the IP through semiconductor to the system and software usage, which is a perfect way to start ladies first as well. So that works out really well. So why don't we start with Dipti, and everybody will introduce themselves real briefly, what they're doing, and how sustainability impacts your day-to-day work, your day-to-day job in your environment. So Dipti, why don't you start, please?
Hello. Is this working? Yeah. Dipti Vachani, I'm the Senior Vice President of Automotive and IoT for ARM. And from a sustainability standpoint, we look at it several ways. Number one, we got to keep our house in order. And so for ARM, we've been very much focused on a goal to be net zero consumption by 2030, very typical of the industry and our ecosystem. But I think it's important that we hold all of ourselves accountable to our own homes. The second part is working on technology and IP that enables the lowest power consumption. And that's very much our focus: low power, small footprints, and the technology we'll build enables that. And lastly, we work across the ecosystem on technologies enabling more sustainability through work with our ecosystems, creating new technologies, creating new standards so that the stuff that we work on can actually scale. We're able to do stuff very, very well when it's one-off or point of just to show something works. But to get this technology and a lot of the technologies that enable sustainability to scale is important. And so ARM focuses on the ecosystem in scale.
Perfect, thank you. So then that's IP, and obviously working with ARM for years, you have been always really brilliant as a company in getting the end user requirements all the way down into the IP requirements. So from there, it goes into the semiconductor components. Intel, as a partner, Jen, on your side, how does sustainability impact your day-to-day work?
Yeah, thank you. Nice to meet everyone. Glad you're here with us today. At Intel, we really think about sustainability from fab all the way to the end user function and usage, and then its end of life. So we're thinking holistically from as we're designing our factories, our next-gen factories that we've opened. We've been focused on our environmental footprint for decades. That has helped us to lower our carbon footprint of our operations, which includes those fabs, by 75% than they would have been otherwise. So we've had a really long journey focused on the fab footprint, and now, we also build products. Energy efficiency, not only at the IP level, at the whole product level, is part of how you got that energy efficiency with so much more compute being packed into the same power envelope. So that's obviously a focus around energy efficiency in the operations on these low carbon products. So, it's both the embodied carbon, built through the fab for the chips themselves, but then also for the platforms and the motherboards. And this is an area we're partnering with DJ and the broader ecosystem to set standards. And I'll let him talk a little bit more about how that impacts, but we work with our ecosystem partners to look at the overall platform, reduce the motherboard, the number of components on it. That's going to reduce your total environmental footprint. And then the system and the data center level. So what comes into that aspect goes into the software as well. So how are we ensuring we're not leaving any transistor behind? Is the software optimally utilizing all the transistors that are in that device or that data center? So that's my role at Intel, kind of looking at all aspects and then all the way to the end of life, the reuse, circularity, and designing that into all the products and partnering with the ecosystem here to drive standards to help us achieve that together. Perfect,
thanks. And that's why I was so excited getting this group together from an ecosystem perspective. So let's start with AWS, perhaps. David, we have been working a long time together on data centers. How does sustainability drive your day-to-day work?
Yeah, thank you, Frank, and thank you for the opportunity to be here today. So in my role, I drive silicon solutions or cloud solutions, basically, for silicon companies, for semiconductor companies, whether they're fabless, they're foundries, they're EDA vendors. Also work closely with our internal teams who are focused on sustainability, for example, our chip development teams. And so if you think about Amazon as a whole has very large sustainability efforts. We're the largest corporate buyer of renewable energy. We're one of the founding members of the Climate Pledge, so there's a ton of activities, and I'm happy to share with those later and invite other organizations to join Climate Pledge. From an AWS perspective, we're very focused on driving down Scope 1 and 2 emissions, carbon footprint for compute, for example, working with our silicon partners to continually eke out more and more performance, and not just sort of data center PUE performance, but making sure that we have the right compute infrastructure for each application in the stack. And that's a super important part of sustainability, not just having everything run on the same class of CPUs or GPUs, but really refining those big heavy lift workloads like AI and ML with custom chips. So we do a lot in this area. We're also very interested in customers now that are looking at scope 3, meaning supply chain impacts, carbon calculators, working with partners such as Palantir, for example, in that area. So we do have a number of initiatives to help customers build out sustainability platforms, analytics platforms, data ingestion platforms to get at those supply chain issues. Really exciting time right now in sustainability.
Excellent, thank you. So talking about the ecosystem, Damesh is here in a dual role, so to speak. You're involved closely in the Open Compute project, the initiative, which is a really cool ecosystem. We can talk more about that. And you're also doing that, representing that as Meta. So your day-to-day sustainability contribution.
Hi, good afternoon, everyone, and thanks for joining today, all of us. Excited to be here. So within Meta, my role spans working across ecosystem, across different technologies. And Open Compute project was launched by Meta in 2011, working with likes of Intel and Rackspace and others. And today you have Google, Microsoft, a lot of other companies have joined Open Compute project. The goal of Open Compute project is to work across ecosystems to solve common problems which are facing data center builders. Now, sustainability is one of the core problems which every data center builder is facing, and there are a common set of ways in which to solve this. So on a regular basis, on a daily basis, my role spans working across various teams to first identify broad challenges which we can bring to the ecosystem. We can work across our partners. We are in process of discussing some data center measures with Intel and see how we can develop that within the ecosystem. We launched sustainability as one of the strategic initiatives in 2021. And the result of that work today is we have developed a design for circularity guide, for instance, which all of our suppliers can use. Oftentimes when we talk about sustainability, it means slightly different things to different people. And it's very important to give very clear, actionable things which suppliers can work on as a starting point. And that is where our work within Open Compute and my work within Open Compute comes in. I also work internally very closely with our broader sustainability team. We have declared 2030 as a net carbon zero across our entire value chain within Meta. Achieving that goal is not something you can do on your own. You have to do that working with rest of the companies who you are dealing with on a daily basis. And within data center, that work becomes very complex because there are a lot of different devices, a lot of different suppliers, a lot of global challenges which we have to solve. And that's one of the areas where we are focusing on, and my particular focus is through Open Compute to solve these challenges for Meta.
Thank you, Damesh. Last not least, Voyen, on the software side, that's why I called you up, software and infrastructure, so the software aspects, figuring out which of my lights at home to switch on and in a city to switch on and off at which point in time is a very key challenge impacting everything. So your thoughts on day-to-day work here?
Thanks, Frank. Great being here. 2010, a group of ARM and Qualcomm people decided to deal with the energy issues, not only of our great processors and IP in general, but for the complete design. So we formed this company, Agios. We stand for Aggregated I/O Systems. And our day-to-day job is to make military devices, portable devices, medical devices, everything that has a battery inside, to be optimal in its energy consumption and thermal profile. Now, that's how we started, but in 2012, we were at the meeting with the California Energy Commission, who just opened this cold plug design center in Irvine, and we got this macro energy bug. So from micro energy or PMEX and transistors, we started thinking about the overall perspective of energy of all electronic devices. And Fast forward, we got involved with the California Energy Commission, Regulation of Computers, Department of Energy efforts on EPA and Energy Star. Canada has also a lot of activities in that space, and it is something which I think gives to every transistor a very different dimension when you start looking at all the set-top boxes and TVs we keep on all the time and consume many terawatts of energy completely doing nothing useful. These are these vampires all over us. So 2 weeks ago, Lawrence Berkeley Lab and U.S. Department of Energy have organized a roundtable in Berkeley, and I'll just bring up my topics for that roundtable. The first topic is that from the great time of cloud, we are moving to the next age, which is the edge age. We have been at the edge, we move to cloud, we go to edge, so it's a cycle. In the edge space, we have certain advantages. The biggest advantage is that we are closer in latency, so latencies are shorter, and we also can DVD impair. So a huge server somewhere in the US doesn't have to be on if I have just to ping some information about how to make cooked eggs or something like this. So I can decide it locally. Latency is very important. A recent comment from one of the technologists was if we would allow latency to drop from 1.2 go up to 1.7 milliseconds, we already with that would save enormous amount of energy. So edge is coming. We need to be aware of the devices which have to be, properly energy managed. The software plays a huge role for reuse, so software has to be emphasized. And then we have a problem how to make these devices really energy efficient, because one of the advantages of the cloud era was the following. You could accumulate enormous know-how at one place, being that Google, being that Amazon, being that any of these great Intel or ARM, and that could disseminate their knowledge in energy efficiency across all of us. With edge, it's different. Edge devices are very different. They're all over the place. There are many producers of these edge devices. We have to scale the know-how of these people now in the edge space, and we can do it only if we do tools, if we do automation on that space. So my point was, instead of expecting that we will be able to have these great experts in edge energy consumption, dealing with everything that was said here, which comes more and more from that side, we should actually help this industry develop tools and methodologies to deal with that in an automatic way.
Cool. Thank you, Moin. And so you have a unique opportunity here. Let's get into the meat a little bit. EDA is this, $10, $12 billion industry. We are serving a $600 billion roundabout semiconductor industry, depending on who you ask. Serving like 2.8 trillion or so electronics. So EDA is this essential but limited piece. You have an EDA audience here, the tool providers who all provide tools to you as users. Where can we make the biggest impact? Not only as EDA, but as an industry, where can EDA help make the biggest impact? So let's start perhaps middle out. David, you had as kind of a user of software and chips and building the whole systems, you had these different categories you're looking at. Is there any area that sticks out where we can make the biggest impact?
Well, clearly at Amazon, we care deeply about power efficiency of our own chips, and we do run substantial EDA flows. We run power analysis, for example. I mean, credit to the EDA industry for allowing these power efficiencies to be eked out of silicon over time. So having higher and higher scales of those analyses, again, whether it's power analysis, design rule check, physical verification, is very, very important. Our perspective, of course, and our experience is that cloud gives us the opportunity to do that in a much more efficient way than traditional on-prem EDA data centers, because you need scalability for those types of analysis.
Right. Is Meta seeing the same thing in terms of where the impact lies?
So if you look at one of the ways in which EDA tools do optimization, very traditional method is power, performance, and area. That's something which is given. It would be fantastic if EDA community decides to find way to include carbon as a fourth element. So if you have a modeling tool where I can now do power, performance, area, and carbon optimization, that would be a game changer in terms of the use of that particular measure. There are a couple of ways in which you can go about doing that. If you look at development of chips, today you are looking at chips growing to the size where now chiplets are becoming the path forward. And use of chiplets leads to bringing different nodes together in system in package. So what does that mean to the carbon element for the solution which you are providing? If you look at the same SoC, which is being built in a 5 nanometer technology, that has an energy intensity roughly 3 times the intensity of a 28 nanometer device. If you look at many functions, especially on the analog side, they can be well implemented on bigger geometries and a lower carbon intensity. So I can develop a same solution looking at chiplet approach where I use mix of nodes and I reduce my carbon footprint. That could be a starting point for EDA to basically come up with a very simple optionality for a designer to consider. They may choose not to consider, but at least it starts bringing these models and these measures into the tool for designer to start thinking of carbon as one of the important elements. Because if you look at embodied carbon, that has become the biggest element of all electronic devices. Not the operational carbon. If you look at iPhone, 2009 to 2019, 10 years, the embodied carbon has grown 3x, whereas the operational carbon has gone down by 1.6x. So that's where we need to focus on using EDA tools.
So carbon, Dipti, you're living and breathing not the carbon, but the making it more efficient day to day with automotive and industrial. So your view on that, where can the biggest impact be made? I mean, automotive under your purview at ARM, electrification, dealing with the carbon footprint and so forth is core. Where can EDA help? What's the biggest impact there?
Well, I mean, of course, I think what you've mentioned is a really insightful thought, because one of the things you're referring to is the analog and digital don't scale at the same level when we get into smaller nodes. And I think you've hit on something really significant as to what the EDA industry could do. More holistically, I think the ability to be able to simulate workloads onto heterogeneous compute, right? That's extremely important when we get to creating efficient solutions. What we've been doing up until now is just more and more horsepower, right? And I don't want to make it that simplistic, but it's often how we look at the problem. At least as I've been walking around the industry and the discussions I have. But if we start to really think about how it is that we optimize the kind of workloads that we have onto the silicon solutions and tying that hardware and software more closely together, and what tools and flows are required to do such, it's a good area for us to focus on, because over time that'll create efficiencies in our silicon footprint and our solutions.
Perfect.
The other thing I want to also mention before is you mentioned automotive and the electrification of automotive, and I'm very, very proud about the work that we do to help the industry move towards electrification. But I also am very fully aware of the other side of that equation, which is the grid, because we are now only making it more and more of an impact on the power grid. And there's a lot more we can do across the industry and how we make that more efficient. So that's another area, I think, not just an EDA, but an ecosystem challenge for us. Is yes, we are moving to more electrification. It's happening really fast, but there's just more impact on the power grid.
You need to get this into the grid, the whole infrastructure as well.
Exactly. We got to look at this problem more holistically.
Right. So Jen, we had chiplet, we have workloads and so forth. You mentioned earlier like the 75% reduction, which was on the operational side there. So your perspective on where the biggest impact can be made?
Well, not to repeat some of the things that have already been said, because these are all, great ideas for the industry to start thinking about. But to take it and build upon what DPD just ended with is for how did we achieve that 75%? Part of that is extensive deployment of renewable energy, right, across our factories. And that's really hard to do. And especially as we head to edge computing, how are we modernizing the grid to be able to handle the onboarding of more and more renewables? That's a massive undertaking as an ecosystem. And so really thinking about modeling not just the workloads and the software-hardware combination, but really starting to think at those solution level. And that's where, we want to make sure as the team, as the industry is moving forward with models, that they're basing carbon models on standards, right? I think the worst thing that could happen for all of us is everybody comes up with their own definition, and now the consumer doesn't have any clue on how to compare. Those are the questions we get from our customers. How do I compare these different models? So I think utilizing standards, convening together to drive those as you're looking at carbon models and thinking solution level, because renewables, deploying them at the edge and everywhere is going to be one of the biggest impacts we can have as an overall global community.
Perfect. And picking up the ball that Dipti shot there in terms of infrastructure, Voin, you have a very interesting and unique and different perspective, because you're dealing with kind of the governmental organizations, if you will, right? The city planning and what can we do at an infrastructure level. Do you see something sticking out there where the impact is? You mentioned the number of lights not being used and so forth useful. Your thoughts?
So when you go into a store and buy a new TV, you will see all TVs being set to the vivid brilliance mode. And this is just a demo mode. And the regulation in US and in California basically is not forcing or promoting that type of mode, but most of us don't need that mode. So back forward to a chip. When you buy a chip, which goes through a standard boot process, sets all the PLLs, all the voltage rails to a certain levels. It is in a brilliance mode. Unfortunately, not many engineers can set that brilliance mode down to a real mode, to a cinema mode, to a real life mode. So we are consuming, especially in the edge, enormous amount of energy just keeping these chips at the levels which are, yes, best for sales, because the highest performance is shown in that particular mode. So I think one small step would be just to kind of allow people to easily put the chip in a shape, and that you have to change a couple of these software components, and that's why I'm a software guy here, in U-boot, in FSBL, in a couple of the standard boot sequences, that these chips are put in modes which you can then scale up or down. On top of that, I'd like to kind of, demonstrate how important this game, I think, is for us. I mean, this whole discussion. 10 years from now, chip industry will be seen in the way like Chevron is seen today as a polluter, a necessary polluter of the environment. So we like all these energy companies, but we would have eventually in 10 years protesters here who would complain about the fact that we have enormously polluted our environment with chip consumption, with not properly disposed devices. At the same time, at the enormous expectations on us. You've seen that you could not buy a car because there was not enough chips. The medical industry was suffering. You could not buy a portable ultrasound device because there was no chips, with a huge impact on the doctors and the nurses. So I think there is a huge responsibility of that topic which we are discussing here. Is not just a nice topic, like a small talk. It will change because chips are a commodity more and more, as essential commodity for our life. And we need to be aware that the communities will ask us to be much more responsible in terms of that. So it's not a big deal to have two modes for every chip you produce. You have your brilliance mode, which is the best mode for sales and for performance. And you also offer immediately a mode which is a lower power consumption mode, which will serve probably around 90% of all the purposes.
Okay. So we are an enabler, but we are also guilty in a sense. That's how I read you there. So how do we measure ourselves, right? So I put up some of the estimates, some of the numbers there. I know we all our companies do ESG reports and Like Deepti, I saw ARM presenting with Forrester. There's like 18% power reduction if you use it right, using the ARM architecture. Of course, there are systemic impacts as well, and EDA helped. So, but do we have the right metrics? I think, Damesh, you touched on that a little bit. I read about PoE and things like that, but then that's really just very data center focused. What are the metrics we as an ecosystem, and I mean EDA here together with the electronics industry, what are the metrics we should be focusing on beyond PoE? Damesh, if you want to start.
Yeah, so all of us know PoE as a well-established measure for data centers. It's total data center power divided by the IT power. We need to go one level deeper, and that's why last year Meta introduced a new measure for people to consider, and the measure we call is hardware usage efficiency. And what we do here is look at the total IT power, not the data center power, because data center power has facilities and other areas which are not directly applicable to the IT power which you want to impact. So you take the total IT power and then you consider it against the useful IT power which you are using for performing a certain function. And that's what we call as hardware usage efficiency. You can do this all the way from server level to a rack level, to a data hall level, to a data center level. The reason why this measure is interesting is because it gives you an actionable thing to work on at a server level. Where do you reduce the power? Can you reduce the idle power? So it gives you a target to work on. So that's one measure which I have in mind. The second measure I want to leave all of you with is, this is something which is just a thought in my mind. I talked about the design for circularity guide. We talk about reusability as a very important element for sustainability. Now imagine I have any piece of equipment, maybe it's this mic, maybe it's a screen here, maybe it's your iPhone. Wouldn't it be amazing if you have a measure which tells you to what degree is that device circular? And what it means is, to what degree is that device reusable? 100% means the device is 100% reusable, and now you go from 100 to 0. You don't need to do anything, just come up with some way to agree on it, and then people will start making self-selection choices. In a lot of countries and economies, reusability is actually a norm. We can do the same thing in the IT space, right? We go through a lot of devices. Storage is one example where hyperscalers go and destroy a storage device because of the security. It would be fantastic if we can find a way to reuse it. So these are the two measures I want to leave all of you with.
Other thoughts, David?
Yeah,
Jen?
I'd like to build upon. Oh,
Sure. Go ahead, Jen.
yeah, I really think about like what is that end user use case and the total carbon footprint of it. So we were even talking about, before the panel, like you should be able to know when you're calling a search, what is the total carbon footprint of the embodied carbon, which includes the life and the reusability of it, as well as the software efficiency. Like, to me, that's the ultimate, is how do we help to enable the consumer to have the data all the way through the stack for their use case. It could be your stream of Netflix that you're watching, or the search, and might you change your consumer behavior? Or, if you're an enterprise, change your behavior to start accepting the latencies beyond that you were talking about. A little bit more, am I willing to accept that? For AI, am I willing to accept a little less precision for much greater energy efficiency? Once we really start focusing on the use cases and breaking it down and optimizing it together, and then building standards and deploying them through a consortia like OCP, well, I think we really have achieved a vision of sustainable computing together.
Okay. David?
Yeah, I mean, from a cloud provider perspective, we don't publish PUE, for example, because to Vijay's point, it's a kind of a meaningless number. It's not getting at what's the utilization, is the right application being run on the right platform. What are the software implications? So from our perspective, how much value can we deliver to customers, whether it's inferences run or higher level services for machine learning, let's say for voice recognition or image processing for a certain cost. And cost, of course, for us includes energy costs. So we're maniacal about squishing out those costs, crushing out those costs, including on the energy side. But we're not going to measure it at a low granular level. We're going to look at it from the application perspective. That's the right level to be measuring energy usage.
Okay. Other thoughts? Always. So let's do the ecosystem aspect here, right? So it feels like nobody can do this just by themselves, right? So Dipti, perhaps starting with you, in your conversations, that given that IP, EDA, we have this fairly unique perspective of like layers of supply chain we are basically working with above. Who are the ecosystem partners that are in the conversation for you? Who are the ecosystem important players, if you will?
Well, gosh, I mean, it is, if you think about automotive, it's all the way across the value chain, right? We work very directly with the OEMs, thinking through power, performance, what kind of power and performance they need, how they're going to redesign their powertrain for electrification. And so we work directly with them. Then we create IP that optimizes their solutions, which you referred to earlier, right? And then we deploy that through the ecosystem. Along with that, a backbone of that is creating standards, working with the ecosystem to create standards so that there is reuse or ability to reuse throughout the channel, right? And so from all of our industries, and each industry has a unique ecosystem, but there's no one, I mean, it's interesting because I spent most of my career creating silicon. And when I joined ARM, it was like, wow, I don't actually make anything, right? But everything I do has to be done through the ecosystem. There is no other way that anything I do sees the light of day unless we work through a combination of a value chain. And so that's important in all of these aspects. I did want to add that one of the things that we're talking about here, and most of our companies have this 2030 goal, right, of net carbon zero, and we're ahead of our goal. And if you look across the board, a lot of companies are, which is really proud to see. But I think that's because we're taking advantage of the low-hanging fruit. It's going to get harder and harder, and the stuff that you were referring to more specifically is the data we need to really hit that goal, because I don't think we're going to unless we have some of this data in front of us to be able to make good, sustainable decisions.
Okay. So then as an ecosystem driver, if you will, as you're closely in the OCP initiative, how does that work in terms of contribution? I imagine there are different interests by different players, right? To Deepti's point, if I talk to an OEM, they have to worry about the grid, the infrastructure, the user experience, and so forth. So how does that, from an ecosystem perspective, play out in OCP?
So within quick background, with OCP, vendors come and they get their devices contributed into open compute marketplace, which then becomes available for everyone to use. These devices don't get contributed into open compute just straightforward. You have to follow, as of today, 4 tenets of open compute. The device has to be open, it has to be scalable, it has to have efficiency, and it has to have impact. What we are doing right now within open compute is we are adding a 5th tenet within open compute. In fact, it's being deliberated right now, and it's going to go through incubation committee, and it will go through voting and all of that. That 5th tenet is tenant of sustainability. So if you are a vendor and you're contributing a server or a hard drive or a SSD or a NIC card into open compute marketplace, you will have to adhere to the 5th tenet of sustainability. What it does is it makes sustainability a vital conversation piece during discussion of which device to get into open compute, and it also increases awareness across the value chain. So this is one of the very important steps which we are taking in open compute. Just to give you a context, the 4 tenants started in 2011, and none other tenants were added until today, where we are starting to add the 5th tenant. So that's how we are trying to move forward.
Okay, okay. So we could talk about this for a long, long time. It's a fascinating topic, and sincere thanks again for you joining today. We have 5 minutes left. Let's do what they call a lightning round. So if you have 1 minute call to action to this audience, to EDA, what's needed, what are the biggest challenges for us to address in the short term to make my daughter and all our kids happy in a more sustainable future, what would that be? So let's start perhaps, again, like in the beginning, Dipti, what is the call to action for EDA and the ecosystem to work on?
I think you hit the nail on the head when you said we can't do it alone, none of us, right? And so it is a partnership. We have to work across the board. I think we're doing quite a bit when it comes to optimizing, creating low power solutions, understanding what that takes, but holistically what the impact is to create a sustainable grid is one that we need to pursue more aggressively.
Okay, Jen?
For this audience, continuing to model the solutions, for each of the use cases, the energy, grid solutions, convening where the industry already is versus starting your own, I think is also, another call to action here. So from wherever you're sitting, come join us where we already are, whether it's an OCP, there's many top, consortia that we're driving to have standards on, the carbon footprinting of the systems. Let's do it together. Let's not do it in 1,000 points of light, because we'll never achieve the goal.
Right.
Yep.
So simulation and basically come to the table. Well, simulation is what this audience is all about. David?
Yeah, I would echo that community aspect. Climate Pledge, for example, we have 220 plus members now. We'd love to have more participation from the semiconductor industry in Climate Pledge. And we've heard some very aggressive goals for net zero. Paris Accords was 2050, Climate Pledge is 2040. We've heard 2030. We can do this together, right? And that means looking at direct impacts, the scope 1, scope 2 of your data center infrastructure, of your operations, and then scope 3 supply chain. Let's really get at that supply chain issue through better visibility of the manufacturing process as well as the operational aspects of running across that deep supply chain in semiconductor.
Damesh?
So I have 4 things I would say. If you are an enterprising person within EDA community, why don't you work together with others to start a sustainability forum in EDA? If you are a decision maker in your company, why don't you launch a conversation about carbon? If you are a person with household, make every decision with reusability in mind. I think with these simple steps, you can start making a big impact over a long period of time.
Okay, Boyne?
I think EDA has long resisted to take care about chips when they are deployed. So it's very often we say they're just throwing the chip over the fence. There were attempts with software, some silicon lifecycle management. I think all of that was discussed here is really urging EDA to start looking not only when the chip is out, when the wafer is out, when it's tested, but along the way. And this way can be very long. In automotive, we are thinking here 30 plus years or 20 years. For mobile phones, maybe a couple of years. But that chip will be around. It needs to be taken care of in terms of energy, in terms of disposal, in terms of safety, in terms of many other dimensions. And the EDA currently is only concerned that chip is out, is well tested, and that the device can move on.
So extending the life cycle, though, that goes back to what Damesh said with the circularity aspect all around. So with 1 minute to go, Tom, my timekeeper here, again, sincere thanks to you as a panel. It's great to have all these different perspectives, so thank you very much. This will be recorded and will be writing. This conversation is, to me, just a start. So I, for one, will go home and look my daughter in the eye and say, we actually do something. We are working on something, and so let's make sure that the future is sustainable there. So thank you very much.
Thank you.